Hello. Throughout this presentation, we are going to present our term project, which is a self-balancing robot that balances itself while rolling off the ground. Now, in this slide, we can see the robot mathematical model which we derived, and on the left, we can see the figure of the free body diagram of the robot. And below, we can see the state space model of the robot.
Now, since we didn't have the parameters of the DC motor and we don't have the exact data sheet, we performed an experiment to estimate these parameters, which are the resistor, the back EMF constant, and many more constant related to the DC motor. On the left, we can see a figure in blue, the experiment data, and in red, the response of the transfer function of the DC motor implemented on Simulink. And now on the right, after estimating the parameters, we can clearly see that there's no error and the model on Simulink can clearly have clearly the same response as the real DC motor.
Okay, so now moving on, we implemented a Kalman filter that will use the accelerometer and gyroscope values to estimate the tilt angle theta of the robot. Now we take this tilt angle theta and the angular velocity theta dot, and they will be the input to our fuzzy controller. For the first input theta, we use three membership functions, negative, 0, positive, each describing the angle of the robot. And the universe of discourse will be from minus pi to pi. For the theta dot, the universe of discourse is from minus 10 radians per second to 10 radians per second, and it will either be negative or positive. And finally, for the output, which is the voltage that will be fed to the motors, we used five membership functions: negative large, positive large, 0, negative, and positive. And the rules can also be seen in this slide. So for example, if we have a 0 angle, no matter what theta dot will be, the output will be 0 for the voltage. Now in the slide, the left video will show us that a bad performance of the robot. On the other hand, the right video will show us a better performance. This better performance was got when we added some membership functions to the initial fuzzy logic, and we also added some rules.
Now, some problems faced while trying to execute our project are the following. First, the main problem that we faced is the weight distribution. Mainly that we were trying to distribute the weight uniformly throughout the robot, and especially that all the batteries and all the weight is located on the above section of the robot. The second problem faced was the wheel velocity synchronizer. We noticed throughout our execution that each wheel had different velocities, and especially that both two motors were fed the same PWM signal. So this was mainly a problem. Another problem is the wheel's contact angle with the ground. The wheel's contact angle with the ground, so also the wheels were not fully in contact with the ground. This resulted in a bad performance of the wheels because we weren't getting the total torque that we needed from them. Now another problem faced is the backlash due to the gears affecting the balance of the robot.
Thank you.